Morning, everyone. Right, so welcome back to another round of Steel Connect webinar. I'm Rocky and your host today to talk about steel and building related topics. So before we start, if let's say you have any questions during the session, during my presentation, feel free to drop it in the Q&A box on the side. So for fellows architects and engineers, if you wish to claim your LAM CPT or PM CPT hours, please stay through the entire webinar. This time around, we'll share the QR code and link of the survey form at the end of the webinar. And you can click into those links and then submit your membership number as well as some of the feedbacks. All right. So let's start with today's topic. So how to score green building points for metal roof systems. Okay, so of course, we know that green building is not just about, one component, but today we'll just focus on what metal roof or metal cladding can do for your building, and also what kind of points that you can score, right? So also to understand the fundamentals of it, of why all these points came about. Okay, so green building. So what are actually green building? Does it have to be green, right? So, or is it just about sustainable building design? Okay, so of course there are many aspects of green building that can be focused on. So throughout the world, there are efforts spent to make sure that people who want to design a green building can refer to certain guidelines or certain minimum requirements. So these type of rating tools are what we call green building rating tools or rating systems. So throughout the world, there are different rating systems. So of course, you can go online and search for it. And in Malaysia specifically, there are also a lot, right? So the more prominent one would be like Green Building Index or Green RE, which is by different agencies. Okay, so of course, in order for you to design or build green building, most often you rely on your green building products as well as designs. Okay, meaning that how you design the building also comes into play. And to more specific green building products, of course, there are also agencies that are trying to make sure that one logo can be systematically recognized to classify certain building products as green. So those are what we call green building product certifications. So in Malaysia, Syrian Eco Label is one of those prominent ones. Of course, like Singapore, US, or Australia. So there are different types of green building product certifications out there. Right. So the gist of these certifications, or even the sustainable building design, today I would like to frame it into a very simple concept, right? So it's called embodied energy as well as operational energy. Okay, so think of it this way. So there are actually two types of energy spent to build a building. Okay, so first we call them embodied energy, and then the second one we call them operational energy. So we revisit this graph after in a short while. So let me just illustrate. So imagine you have a project where the groundwork is been done. So the energy used to excavate, for example, a site, and the energy used to build the structures, and also the energy used for all the building materials to be manufactured and transported and also installed onto the building sites, right? So all this energy will be calculated together, and also we draw a line when the construction is completed. Of course, throughout the building lifespan, if let's say there is any retrofitting, then those will be also counted into this embodied energy, right? Then when the building is in use or during the usage time, there'll be energy, right? Like electricity, water heater, cooling systems, and whatnot, that is used to operate this specific building. So these are different types of energies will be classified into embodied energy and operational energy. And for embodied energy, it is just now what I mentioned, and hence it is, as you can see from this graph, it is almost constant, right? As soon as the building is completed. But then you can see an instant height at the building age of 0 years old. Whereas for operational energy, you get a gradual increase, right? And this is just a very extreme simplification of how the energy use will look like in terms of the trend. So what you can notice here is that operational energy will increase accumulatively over time as the building is in use. Okay, so these two are very important concepts for us to use during my presentation later on. So I'll link some of the aspects for metal cladding to these two specific energy use and how it contributes to this different energy. Right. So the first one is what we call recycled content. So for metal cladding, of course, we use different types of metal, but prominently we use steel, right? So in steel, it is recyclable. So of course, let me just show you to the upfront. So in different rating tools, you can actually score different type of different possible range of scores for recycled content of the metal cladding. All right, so of course you can search online for all these rating tools for different type of building. Yeah. So, but the idea is that steel itself is virtually recyclable, like 100% recyclable without any degradation, right? So you can recycle it without worrying that the quality on the long term will be degrading. All right, but of course, doing so we have to consider the life cycle of steel. Okay, so from raw material extraction all the way to usage, right, installation, and of course recycling. So the emphasis here for recycled content is the last part, where we get the offcuts or even the waste or scraps, we call them, from the construction sites to the recycle or the upstream process of making steel. So of course here I would like to highlight two terms. One is called pre-consumer recycled content, as I highlighted, and another one is called post-consumer recycled content. So these two factors will be used to calculate the overall recycled content itself. Okay, so just a simple, for your simple understanding, pre-consumer recycled content means that the scraps that are generated when the product is still in the production stage, right? So those offcuts from those production stage will be sent to recycling. And then the second one is called post-consumer recycled content, which is used to, which is sourced from, say, construction sites when the building has reached its end of life. All right. So is the recycled content, calculation is not as simple as add the post-consumer plus pre-consumer, but it works this way. 100% of the post-consumer recycled content, for example, you have a certain amount, then plus half of the percentage of pre-consumer recycled content. That gives you the overall steel recycled content. So for example, if let's say in my steel I have 5%, I throw in 5% of a post-consumer recycled content and 10% of pre-consumer recycled content. What does it give me? Okay, so here you can see the calculation is very simple. It's 5% plus half of the 10% pre-consumer that gives you 10% overall recycled content. All right, so based on those different rating tools, of course, the minimum requirements to score a certain points, certain level of points is as you can see here. So certain rating tools like Green RE or Green Marks, they do not specify the types of the percentage of recycled content. Rather, they would emphasize on green product certifications. So the reason why for this reference to product certification happens is because certain product certification has already put in this requirement in terms of the minimum recycled content for certain product. That's why it is more consistent for them to refer to the green product certs. But for others, it's much more specific, right? So, right, coming back to this, life cycle. Okay. So, what I would like to emphasize today is the next trend, right? So, counting recycled content is not going to be the stop for this, to make sure that there is a circular, flow of material. But the next step here is environmental product declaration, or in short, they call them EPD. Right. So what environmental product declaration means is that we will actually classify the product life cycles in different stages. As you can see here, there will be 5 stages: production stage, construction stage, use stage, and end of life, and also last is the resource or recovery stage. Okay, so of course, our counterpart in Australia, actually they have done such a study, and again, this study is cannot be generalized for one product or for one company. It has to be applied throughout. Applied for that specific location, specific so-called production site. Okay, so this is done in Australia. So I'm just sharing you what is possible, right? So of course, for steel production on our upstream, we are involved in the production stage, of course, the end of life, part of the end of life stage, as well as the recovery or so-called resource recovery stage. Okay, meaning recycling. All right, so here you can see, based on certain standards, you can classify different stages in different so-called letters. So A for production stage, then C for end of life, and then B for resource recovery. For B is for usage duration. Okay, so the X means is where we declared the energy use. So of course it looks something like this on a more detailed level. So you can see it's very specific to a certain location, because aside from all these locations, the transportation also counts as part of this EPD assessment. So I extracted out the gist of what I'm going to show you today. So of course, part of this EPD declaration is that you need to calculate at different stages of the life cycle, how much impact does it cause to the environment. Okay, so of course, these are just emissions to CO2 emissions in this specific process, the sulfur dioxide emissions, which contribute to acidification, also called acid rain, right, in layperson's term. And of course, the energy depletion for natural non-renewable sources like fossil fuel. All right. Then of course, there is also aspects of calculating the energy, total energy use for different processes. So if you count the keyword energy, you're right. So because again, we are linking back to the embodied energy here, right? Recycled content, it means that the energy spent to produce this amount of steel, and that energy will be calculated into the material itself, and then when it's used on your site, then it is considered part of the energy used for the building itself to build that building, right? Then of course, last but not least, some other potential hazards, by these different processes. Right. So of course here, if let's say you look at certain figures like what you can see here, E negative 4 means actually 10 to the power of negative 4. It means it's very, very negligible. All right. So there are certain numbers that you should be aware of. But anyway, you can actually download this. It's a publicly public document where you can actually download as your reference. But again, it's not generalized, right? So you cannot use it for other countries or other production line, especially in Malaysia. All right. So there are also green points that are applicable for the solar reflectance index. Right. So just now the recycled content I mentioned is for embodied energy. So solar reflectance index is to calculate the performance, is to measure the performance of the building during its operational life. So this will be contributing to the operational energy side, right? So what is solar reflectance index, right? So I'll get into it later on. But first, let me just share with you some these are the scoreable points for different rating tools. Right, so what you can see here is that, you know, on average of 2-3 points scoreable. Okay, so over here, what you can see is that this is a thermal image, you know, taken using a drone of a certain urban area. And what you can see here is that, you know, there are actually different radiation picked up from the photo, right, from this thermal image. So I'll get back into this photo on later on, because I want to explain to you the basic principle of thermal transfer, so-called heat transfer. Okay, so heat basically means that, you know, from one source of heat transfer to another heat, right? So here there are actually 3 mechanisms where heat will pass on from one body to another body, or one medium to another medium. So those 3 are conduction, convection, and radiation. So how does these 3 work? So let me go by in this order. So first, radiation. So I use this specific example of you know, a campfire and then heating up a stove of hot water. Okay, so the first is radiation, where when you have fire or when you have any heat source, that heat source itself will emit radiation. So the most common radiation that we expose ourselves to is sunlight. So yeah, like vitamin D, or, you know, when you stand under the sun, those are the exposures that you are getting. So there are, of course, very harmful radiation. There are also not so harmful radiation. So the sunlight radiation is not so harmful to a certain extent, right? So yeah, so that is the first, you know. So radiation does not require medium to transfer. So it can be transferred through air, through vacuum, right? So this is the first one. So the second one is what we call conduction. So in this specific example is where the metal itself gets heated up due to the radiation, and then from there it transfers the heat through from the you know, the closest part of the radiation to the you know, furthest part of the radiation, right? So from here it will heat up the whole metals itself, the homogeneous metal itself. Of course, the third one mechanism is where it heat up the water inside. Okay, so of course, liquid, I mean, water inside is considered a liquid, meaning it can flow. Okay, so in this sense, the water will start moving around. So that creates what we call convection. So heat will transfer as the water goes around. Okay, so and of course, when it evaporates, then this is another form of convection, where it gets blown away by water, I mean by air. And the air itself will actually act as a mechanism for convection, right, to cool down the surface, or even the metal itself. Right, so these 3 principles are very important for this topic of solar reflectance index, because as I mentioned earlier, you know, if we stand under the sun, the most common exposure of this you know, solar, I mean this type of heat transfer is sun, right? And for sun, the most common exposure of heat transfer is radiation, right? So it's not very harmful, and the part where it will actually cause your you know, building to heat up is the near infrared side. Okay, so there are actually different spectrums of so-called sunlight, which we have covered previously in a certain occasion. But today I would like to focus on the near infrared spectrum of the sunlight. So the near infrared spectrum of the sunlight is not visible. That means you cannot see it with your naked eye, right? But it will actually be felt through different medium, which is heat, right? You can feel the heat, right, if you stand under the sun, but you cannot see how it transfers to you. So how it transfers to you is through radiation. So let me share with you how it heats up the building, right? So when you have the sun and then you have your building, so if let's say your building is in, for example, a black color, right? So today I'm using a roofing sheets, black color roofing sheets as an example, but it can be any other material, like, you know, it can be tiles, it can be asphalt, it can be bricks, and so on, right? So all these different materials or different finishes, it will actually react to the radiation very differently. So for example, if I have black colored roofing sheets, it will actually reflect less of the radiation back into the environment, meaning it will absorb a certain extent, the radiation. So the arrows that you can see here, it represents the radiation. So 3 arrows coming down, but only 1 going up. Okay, that means they are absorbing 2 rays of radiation, for example. But if let's say you change the color of the roofing sheet to gray color, then more of the radiation is not absorbed, but is reflected. All right, and the surface temperature will be reduced. And of course, if let's say you have a lighter color like white color, then most of the so-called radiation can be reflected. All right, so that means you will not heat up the roofing sheets so much. So the example here shown here is that the roofing sheets for this white color will be 40 degrees Celsius. Right, so that aspect of the material is what we call solar reflectance. Okay, solar reflectance. So we are getting closer to understanding what is solar reflectance index. So this is the first aspect for you to understand solar reflectance index, or SRI. Of course, the second one, which is much more tricky, but is sometimes misunderstood. Even for me, initially when I did the study of this topic, I was also misunderstanding what is thermal emittance. So let me just share with you the understanding of this. So for example, if you have say a different material, so this one, thermal emittance, this aspect of this SRI depends on the type of material and also the type of surface, right? So if let's say you have a clay tile, right, and the clay tile itself, temperature is 70 degrees Celsius. The amount of radiation that it is re-emitting back to the environment is very different, right? So if let's say you use a thermal camera like what you can see from the top picture here, it picks up different level of infrared signal from different material, like the dog, the grass, the background behind. Okay, so if let's say I change the material to pre-painted steel, for example, the temperature of this material can be 70 degrees Celsius. But if you use the thermal camera to measure it, you might pick up different temperature, right? So you might have a reading of 45 degrees as opposed to just now 65 degrees. Okay, so what is interesting is that thermal emittance is a measure of how much radiation one body re-emits back to the environment. So it is also highly dependent on the type of material, the type of finishes, and so on. So to further illustrate this, let me just show you one example that I've captured recently. So having locked myself at home, this is what I made, right? I mean, there's a toaster, and then there's a thermal camera capturing how this toaster works. So what you can see is that there's those grills that are heating up the chamber, heating up the whatever inside, and as soon as you close the lid at the front door, right? What happened is that you can see there is actually very different signals of heat being picked up, right? So this is because the glass that is on the cover, it has a different thermal emittance compared to the material inside. Okay, so that is how it works. So here, another thing that I like to highlight is that you can see the tray inside is meant to be in the same temperature as the chamber, which is 150 degrees Celsius. But what happened is that when you use a thermal camera, you are not picking up that signal, because that is not the the amount of thermal emitters, or so-called the amount of radiation being emitted back from this tray back to the surrounding. So these two are very important aspects or factors to calculate the solar reflectance index. All right, so of course, solar reflectance index, by simple terms, it means that how much of energy is being absorbed and re-emitted back to the environment, right? So ideally, if you have a higher solar reflectance index, then it is good to reduce what we call urban heat island effect. Okay, that means it will absorb less of the radiation from the sun I mean, that is the largest source of radiation, right? And it will also emit less of the energy back to the environment, right? So these two are the things that you use to calculate. So you can search online for this calculator. So it's very easy. So SRI is a calculated value based on the solar reflectors as well as the thermal emittance. So you can search online to input all these different figures, and then it will definitely calculate for you immediately what is the solar reflectance index for different material, and different colors. So of course, another aspect of this is that you also depend on the type of convection, the type of wind speed, which is convection, in your specific environment. Commonly used figure of assumption will be on the medium wind speed, which is in the middle. So here, one example I'm showing you here is giving you around 77.7 SI value, and this is a unitless value. All right. So of course, for our colors, I mean, this is our examples, but it applies throughout different, building envelope materials. Yeah. So what you can notice here is that the higher SI value is normally on a higher, on a lighter color, and vice versa for the darker colors. And let's go back to the picture that I showed you earlier. What you can see or what you can notice here is first, let's establish the understanding. Yellow color means high solar radiation re-emittance, meaning it will emit back to the environment more of the heat that it absorbs. Right, so the thermal camera here picks up the radiation that is being emitted by different material. And purple here is on the other spectrum. It means it is emitting lesser of the radiation. And of course, there are two spectrums here, and then the highest radiation being emitted is asphalt route. So that's why you might have seen certain studies about changing the asphalt route material to something else, to a lighter SI value material that at the same time can be functional. Again, you need not sacrifice the performance of the material by looking for something that is green as well. So the other spectrum is the tree, right? Tree, as understood, is a green. I mean, is where most logos are deriving their logos from, right? For green building. So tree themselves absorbs very little. They absorb solar energy, but they translate it into different energy. So they don't re-emit it back. So that's why the radiation signal picked up from this infrared camera is very, very low, right? So that's why you see, there are also green buildings that has a lot of scores for, if let's say you have a green landscape and whatnot. And of course, if you look closer in the middle, this is where I want to highlight to you. So on the left, you can have a white roof, and on the left, you have a gray roof. All right. So here you can see the temperature pickup. The radiation be emitted from this different material is very, very different. So the white color roof emits lesser heat compared to the gray color roof. So this, on a hindsight, it shows higher SRI. It actually will be much more better for the environment and for the building itself. Okay, so of course, there are also nuances to how you can actually select the material, right? So certain materials comes with clean technology, certain material that do not, right? The reason why is because if let's say you have a material that can have a self-cleaning ability, right? So this does not just apply to metal roof, but it also apply to say glasses, windows and whatnot. So if let's say it has a certain self-cleaning ability, it will be able to make sure the color is lighter in color. So lighter in color means the SI will be naturally maintained at the original state, as opposed to getting dirtier and reducing its SI value. All right, so of course, is higher cleanliness directly means higher SI value. All right, so of course, the judging criteria, the minimum requirements for all these grading tools are very different. But I would like to highlight lead from US, right? So one thing that they have changed in terms of SI requirements approach is that they also stated down the performance requirement, meaning after 3 years, the SRI value should not reduce down to so much, right? It should maintain above this other figure, because they acknowledge that, you know, the material, building material gets dirty, you know, gets darkened, gets stained over time. So this is one of the you know, more progressive way of controlling these aspects. But again, you can actually use this knowing that if let's say you score this point, is to reduce you know, the urban heat island effect. Okay, so I won't delve into this deep today, but if let's say you guys are interested, we can create another sessions just for this explanation. Yeah. So last would be the thermal transmittance. All right. So commonly understood as U value. Right. So as you can see from the diagram, thermal transmittance means how much heat transferred from outside to inside or inside to outside. So of course, I'm speaking on the context of Malaysia or, you know, Singapore, you know, all these tropical countries, where typically it will be hotter on the outside, and then it won't change. The scenario won't change to hotter inside and then colder outside, because we want it colder inside, right? So the heat transferred inward, right? How much of it, right? That is what thermal transmittance is, right? So here you can see two different diagrams, one with just brick wall and one with brick wall, and on the right, those are the insulation layer. So of course, scoreable points here are, you know, it range very differently. The reason for this is because, don't get me wrong, yeah, there are different rating tools for different type of building. So I'm actually merely using the house rating tool here to actually get, you know, to study it and also see what are the points that are applicable. Of course, leads themselves are much, they do not just look at these thermal transmittance, they look at the envelope thermal transmittance, meaning the whole building's thermal transmittance, right? So to ensure that it is covered completely. And of course, this one relies a lot on the conduction aspect of the thermal transfer. Okay, so again, I mentioned earlier, it applies to not just you know, the roofing segment, it applies to the whole building envelope, right? So but most commonly you have, you know, roof as the primary area that is sun facing and expose the longest hours to the sun. So that's why it's commonly required for sun, or commonly highlighted for the roofings to have certain thermal transmittant value or U value. All right, so I'll use the U value because it's shorter. Right. So here I show you two different types of build-up system, right? So one has you know, more build-up than others, but what I would like to highlight here is that the insulation layer is crucial to contribute to the thermal transmittance value. And let me just get into deeper on why is that. So for example, if you have metal roof, then there's a certain amount of heat that is transferred inward, and there's a certain amount of heat that is repelled, right? That is re-emitted outward from the roof. Okay, so the metal roof itself will get heated up, again, depending on the SI value. So it will heat up to a certain temperature, and then it will re-emit the heat to the surrounding, either inward or outward. So of course, lower SI value, it will emit more of the heat back to the environment, meaning inward and outward. Yeah. And of course, if let's say without any you know, insulation layer, then more heat will come inward. Right. So that is the basic understanding here. But if let's say you add a certain amount of insulation at where the place where you want to insulate, then lesser heat will be transmitted inward, and then most of it will be repelled outward. Okay, so this is to you know, make sure that, you know, if let's say in for example, a tropical country, or for example, if let's say you're a four-season country, then during the summertime, then it will feel less heat when you are staying indoor. All right. And the more insulation you have, you know, the more so-called comfort, or so-called the less thermal will be transmitted through the wall or through the roof. All right, so linking it back to this thermal transmittance or U value, you can actually calculate U value by getting the thermal property of different materials. Okay, so it's not just relying on the thermal properties of one material, but all the materials that are shown or that are using for your build up. So the thermal properties that you should look for is called R value or even K value. So thermal transmittance is derived from thermal resistance or even thermal conductivity. All right, so from there, there's simple calculations that you can find online, which I've shown a very simple one on the left here. And then, of course, from there, you can get a U value, right? Then U value represents, if let's say you have a higher U value, it doesn't mean it's good, right? So as you can see from the right, you know, U plus means increased U value, means less resistance towards the heat transfer. So your building internally will be heated up, you know, as much as the external building. So if let's say you decrease the U value or so-called decrease the thermal transmittance value, then the heat transfer will be lesser. So ideally, you want to have lower U value over here. So if I show back the examples that I've shown earlier, if let's say you have just merely a metal cladding, you know, the U value can go up to more than 4 watts per meter square Kelvin, right? So this is the unit of U value. It's not unitless, yeah. So U value for metal roof can go up to as much as 4 watts per meter square Kelvin, right? Even more, right? Also depending on the situation, the condition, right? The color itself. Then for U value for insulated panel, built out systems, right? It can go down as lower than 0.4 watts per meter square Kelvin. Okay, so of course, what is the ideal or minimum requirements for this build-out system? Right. So for different rating tools, again, they use different type of so-called requirements or different values. Yeah. So of course, the straight up answer to you is over here. So GPI less than 0.4 for you to get minimum 1 point. Of course, if you improve, that means if you reduce the U value for your build-out system more, then you are eligible to more points. So if you recall, just now I mentioned 10 points, right? So those are the eligible points. Let's say you really want to improve the roof system's insulation level, right? So for green RE, the minimum requirements for roof is 0.35 watts per meter square Kelvin. And of course, some rating tools, as you can see here, like LEEDs, they never mention the U value for roof, but they refer to this S-ray rating tool or Advanced Energy Design Guide. So what 50% means is that, if let's say you follow this guide, it's likely for you to achieve so-called 50% energy saving on the operational energy level, right? So you aim to reduce the energy by 50%. So just imagine monetary wise, you can save your electricity bill by half. So that's what, I mean, I'm oversimplifying it, but that's what it's saying. Okay. Then, of course, for something like Green Star, which is used in South Africa, so they are actually highlighting the roof insulation thermal resistance value. So of minimum of 2.4 meter square Kelvin per watt. Okay, so of course, these can be again translated into U value as soon as you have a built-up system. Okay, so so I won't dwell too long on this. So of course, having done all that, you know, a lot of investors, they will ask, what other incentives do I get, right? You are just showing me the improvement of the building. But if I don't live in the building, right, someone else does, then it's actually a strong point for them to go green now, because there are a lot of solutions out there, and not to mention the types of incentives. So what I'm showing you here is one incentive that is only applicable in Malaysia. But of course, I'm sure throughout different countries, there are different incentives to push investors or to encourage investors to go green. So in Malaysia, it's called Green Investment Tax Allowance, where when the building owner, the investors put a certain amount to you know, go green, right? Buying green services, green products, they are entitled to a certain amount of tax allowance. Okay, so again, aside from that part of you know, the monetary benefits, of course, let me just close or conclude it, coming back to the energy usage. So just like I mentioned, embodied energy as well as operational energy, right? So what we are aiming to do by all these you know, different aspects of green building improvement is we are essentially reducing both the energy use, right? For embodied energy, it means that you use less energy to build the building, right? Both from considering from the how the material is manufactured, all the way to how it is you know, built on site. Okay, so with the declaration of something like EPD, then you can even reliably calculate it better. Of course, for the operational energy, so throughout the lifespan of the building, you can actually safely reduce the energy use to maintain that building itself, meaning you don't have to sacrifice any creature comfort or any types of performance requirements, right? But you're just merely saving the you know, energy use, right? So those are the so-called not so immediate impact that sometimes investors might not see but need to be highlighted. Okay, so with that, let me just quickly conclude today's session. So I covered the recycled content. So today I segregated the 3 points into 2 parts. So recycled content, which is used, you know, which is to increase the recycled content of a material so that the embodied energy of the material being used will be drastically reduced. And of course, solar reflectance index as well as the U value, or so-called thermal transmittance value of the roof or metal cladding system, it can be improved to improve the operational energy side of things. So whatever I highlighted earlier, those are recorded, so you can actually go back to our YouTube channel to watch it again if you want some specific statement from me. All right, so with that, let us just go to the question and answer session. All right, so again, just a reminder, if you have any questions, just post it in the Q&A box and I will address to them one by one. Yeah, questions that are not so relevant to this topic, then we'll address it offline. Right, so let me just go to the first question. So from CS Low, so does it mean that green reflection also good in thermal emittance? When you say good reflections, I assume you are referring to the good solar reflectance, right? So what you're saying is that if, let's say, good solar reflectance, does it mean also good thermal emittance? So my answer to that is no, does not mean that it will have a good thermal emittance if, let's say, it has a good reflection. So what it's saying is that if, let's say, a material is in a matte finish compared to it being a gloss finish, the thermal emittance itself will be different. But then solar reflectance it is highly reliant on the color itself. So I hope that answered your question. Okay, so CSLO, you have a follow-up question. Is that U value is also to take into consideration the air gap between the roof and ceiling space? Yes, the answer is yes. U value, it takes into account of basically the build-up, whether it be an air space, but of course, airspace, you need to consider whether it's a static air or it's a flowing air, right? And also ceiling space. So, of course, one of the tools that I found useful to actually address this is the ASHRAE. Yeah. So you can see here. So ASHRAE. So if you search ASHRAE, Advanced Energy Design Guide online, you are definitely going to get you to the guide book. Yeah, where you can actually download it for free. And under it, it is able to give you certain guideline on what are the things that can improve U value. So I hope that answer your question. What's the procedure to apply for Green Building Certificate in Malaysia? Cost, timeline. Okay, so of course there is no set. Wait, you're talking about Green Building Certificate. I'm assuming you're referring to say GBI or Green RE and all that. So the procedure it depends on the rating tool itself. So different rating tools, there are panels to actually judge, how your submission or your design can be considered green or not. So the cost and also the timeline depends on the type of rating tools that you are using. Yeah, so it also is linked to different types of different body that is using the rating tools and also judging based on the rating tools. So I hope that gives you some idea. Yeah. So because I'm not the one doing the so-called judging, so I will not have a clear idea on what is the timeline and cost. Is there a comparison of SRI, U value, etc. between metal roofing sheets and cement roof tiles and other conventional materials? Thanks. Currently, we do not have a straight up comparison between roofing sheets and cement roof tiles. The reason is because actually there are a lot of different so-called types of clay tiles or roof tiles, cement tiles, and different materials or different colors. It contributes to the different SI value. And of course, metal roof. Normally, you don't use it alone for housing. For example, you use it with a certain insulation infill material, right? So that helps you with the U value. By looking at the roofing sheets itself, the U value itself is quite low because the roofing sheets itself, metal roofing sheets, yeah, it has quite a high thermal conductivity, right? It conducts heat very well. That's why when you calculate it to U value with just these metal roofing sheets itself, I mentioned earlier, normally you get more than 4. So I have not really done a calculation on cement tiles because there are actually many factors. Thickness comes into play, right? So thickness, whether formally they are using insulation or not. So those are the things that are coming into play. But of course, if let's say you have an existing cement roof tiles data of solar reflectance, and then you want to compare to a specific color of ours, we can actually have an offline discussion on this, and I can show you how it is done. I mean, the comparison and so on. The next one is, could you give us more details or explanation on GITA? Interesting incentive. Yes, of course, GITA, as I mentioned earlier, is green investment tax allowance. So I do not own the data, so I do not own the guidelines. So you can always search online, green investment tax allowance, and then it's owned by MIDA, right? Malaysian Investment and also Development Authority. right? So over there, you can find all the guidelines about how you can apply for it. And of course, it depends on your building itself, the building that you're designing. Most often, the ones that they are very good at navigating it is if let's say you are searching for, say, green consultants, there are actually a lot of green consultants out there, right, in different part of the world, and then this is part of their job to actually give you some recommendation as well. So yeah. Okay, so next one is by Joe. So how do you factor in SRI into the U value calculation? So over here, okay. So over here, the calculation of U value actually does not take into account of the solar reflectance index. So what I'm saying this is because U value measures the thermal conductivity, meaning how conductive is the material itself. As I mentioned earlier, there are three methods or three mechanisms of thermal transfer. So the first one is conduction and convection and radiation. So solar reflectance index merely gives you an index of how well it reacts to solar, how well it absorbs energy and re-emit it back to the environment, right? So again, it breaks down into two parts. Okay, so the first part is solar reflectance, and the second part is the thermal emittance, right? So how well it absorbs the radiation and how well after it absorbs the radiation, how well it re-emits the radiation back to the environment, both on top and bottom of the metal sheets. So basically, you are measuring two different aspects of the thermal performance, but one in the aspects of radiation, another one in the aspects of conduction. Yeah. So I hope that answers your question. So Lee, so your question is higher thermal emittance means building will cool faster. Isn't that better? My answer is yes and no. Okay, the reason why is because we cannot just look at the thermal emittance itself and judge whether the building will cool faster or slower, because you also need the solar reflectance aspect, right? Because if let's say you only look at the thermal emittance, for example, certain material has high thermal emittance, but it also has a low solar reflectance. That means it absorbs a lot of the radiation from the sun. So what you are doing is making the material itself that has such a high thermal emittance but then low solar reflectance to be another source of radiation that is emitting a lot of energy back to the environment, not just the top, but then also at the bottom. So this will result in, again, come back to the SRI value. Right? This will result in a very low SRI value. And what happens at the end is that it will actually increase the urban heat island effect, which is what you don't want. So merely looking at the thermal emittance itself is not really it doesn't give you a complete picture of whether it's good for your building or not. So you need to look at the solar reflectance index instead. Okay, so I hope that answered your question, Lee. So how do you factor in SRI into the U value calculation? Okay, so I think this one was already answered. So Joe, another question is, in these, do they consider the dirt pickup for SRI retention? I don't. I think they expected the SRI to drop because of certain dirt pickup. So yeah, I do believe that they take that into consideration, and they also take into consideration of the color change of the material. Meaning, if let's say certain color fades, but normally fades we don't know what is the SRI value, so that's why it depends on a lot of things. So it doesn't mean that it fades to become lighter, then the SRI value will be better. So it depends on the material itself. Okay, but go back to your question, that pick up, yes, I do believe that is part of the consideration. Okay, in your calculation for U value, do you consider bridging? What is the impact? Thermal bridging. Okay, so yes, actually, this is a very good question. So a lot of the U value calculations, it just bypass the whole systems. So the whole system means you have the Z spacing, right? Z spacing, so called. So the Z spacing itself, it will actually act as a thermal bridge, meaning it will bypass all the insulation and transfer the heat downward. But of course, it depends on the level of the amount of Z spacings that you have. One interesting thing is, for the S-ray calculation that I mentioned earlier, they do consider this as part of their. Wait, let me just go. All right. So this S-ray, advanced energy design guide, they do give you such aspects how to actually prevent that. But in terms of normally, when I see U value, when people ask for U value, no, this is not part of the consideration, but it should be part of the consideration. So if neglecting such thermal bridging from the consideration, what you will get is that you will see the performance, the actual performance, might not be as good as what you expected based on the calculation of the U value of the building system itself. So the two S-ray, it gives you an insight on how to actually calculate it together with the Z spacer. So next question from Yuan. Yuan, does thickness in BMT make a difference on the SRI value? You did mention color make a difference. The short answer is no. Thickness in BMT does not make a difference in terms of SRI value. Because again, I mentioned it relies on the so-called color as well as the type of finishes, right? So it does not depend on the thickness, which are not exposed to the radiation, right? But it does act as a thermal mass, or in engineering term we call them heat capacity, right? Thermal mass, heat capacity, both are the same, referring to the same thing. That means if let's say you increase the material bulk, it will store more energy, and this will contribute to say the U value, right? That will be affected, but not SI value. The next question is, Singapore BCA encourages using material with a low LRV, so light reflectance value like LRV. How will this impact the green building, considering since the lower LRV means using a darker shade? Okay, so of course, when you are looking at LRV, it means okay, so for Singapore BCA, when they mention LRV, so it's mainly to prevent so-called the glare from happening. So what happens is that lower LRV, you get lesser impact on the environment, so lesser glare. So I personally, I don't think this is the approach where the LRV will help with the so-called urban heat island effect, or so-called the glare. So normally for glare, we look at gloss unit, which tells you straight up what is the reflective the amount of visible light being reflected. And as for the heat, also called the green building aspect, we prefer to look at from the solar reflectance index point of view, because as I mentioned earlier, it literally relies on the solar radiation, and based on the SI value, you can judge very easily, based on the material itself, how much energy is being emitted back to the environment, right? So LRV for us, we don't see as relevant as SRI value. So next question. Okay, Yuan, Does metal sheets profile make a difference? Metal sheets profiles. That means choosing different type of metal sheets profile. Does it make a difference in terms of say SRI or U value? I believe it does to a certain extent, but how much of a difference that depends. But again, I don't think it is easy to calculate. So I don't know whether anyone will give you a straightforward answer, say, how much improvement or what is the difference. So so far I haven't seen such analysis yet. But yeah, it does make a difference, I believe, because of the different level of shading, different level of surfaces, different amount of surfaces rather, and different amount of airspace within the built-up system. So for me, from thinking from that perspective, it does make a difference. It's just whether people can actually calculate it. If let's say no, then they'll tell you an answer. Most likely it's not going to make a difference for scoring GPI points or green building points. So what insulation is advisable to be used to reduce the thermal transmittance and comply with bomba requirements? Okay, so I believe there are two parts to the question. So first part is what type of insulation that will be helpful to reduce the thermal transmittance. I believe that's what you're asking. And the second is the type of insulation should also comply with bomba requirements. So from that aspect, let me just address the second part first, because I think safety will be the underlying requirements instead of the green building. Safety would come first. So I would say, as long as the material itself is non-combustible, and it should be safe. In the case where the insulation layer itself is cannot confirm to you that it is non-combustible, then you might want to get it tested. If let's say it is used for wall cladding, because there is a certain minimum requirements of for it to be used as roof, and there's a more stringent requirements for it to be used as wall cladding, which in the previous webinar we have highlighted this, so you can always go back and check it out, our previous webinar about the new requirements for wall cladding. And yeah, based on that itself, bomba will give there'll be more stringent requirements from bomba's perspective. And if let's say there's any change in insulation and it has not been tested, I believe bomba will ask you to go for a thorough test to this according to this British standard called BS 8414. And yeah, so if let's say that passes the requirements, passes the test and passes the criteria, then the safety side is secure. But in terms of whether come to the second question about whether it will reduce the thermal transmittance value. So the same type of insulation, if let's say the supplier that you are referring to can offer, a thicker insulation. So naturally, when we think about insulation, the thicker means it will be much more insulative, right? And also more density, I believe, will do the same as well. So what happened is that you need to seek recommendation from that installation supplier, see how you can reduce it to the requirements of your building. Yeah, so it starts from your requirements of your building and then find a solution. So I hope that. So last question of the day is, from the U value calculation, it seems no direct correlation with the SRI or color shade. Does this mean a dark color roof will show similar U value for a white color roof if both are using same built-up system? Yes, the answer is yes. As I mentioned earlier, U value and also SRI, they measure very different things. U value measures the thermal conductivity. Yeah. So how much energy passes through the material itself. Whereas for solar reflectance index, it measures the reaction it has towards the solar radiation. So again, absorbs and how much of it is re-radiated out. So that's why you can see a lot of the green building tools, right? They do not put the SI value under the energy performance. I mean, there are some that do that, but most they will refer it back to more towards the environment, meaning how much of this material will cause urban heat island effect. So recently I've actually taken a photo, which I didn't show everyone, is if let's say you use the thermal camera and then you take it from a high ground, you can see, different time of the day, you can have different thermal images, because different buildings, they will actually absorb different level of radiation and then heat up that environment in turn. So sometimes if let's say you live in a landed housing, you live in a urban house area, you might feel, oh, it's very hot. Why is that? Most likely is due to this urban heat island effect. Yeah. So by reducing that, by increasing the SI value, by having more greens around your houses, it actually helps with reducing this urban heat island effect. So I hope that gives everyone here some perspective of so-called the green building for metal cladding, and that concludes our Q&A session. And of course, like I mentioned earlier, for architects or engineers who wish to claim your CPD hours or points, just click the survey form here, or our host will actually paste the link in the chat box, and then you can actually click that link and then fill up the survey form. Yeah. So with your so-called architect or so-called BM or LAM membership number. Okay. So with that, thanks everyone, and hope to see you guys again soon.